Hey everybody, and welcome to our session. This is OSCAL in Action, Real-World Examples of Automating Policy and Compliance. And I'm Jen Power. I'm a Principal Product Security Engineer at Red Hat, where I spend most of my time working on compliance automation and standardizing security and compliance relevant data.
And I'm Hannah Braswell, an Associate Product Security Engineer at Red Hat, where I work with Jen on compliance automation and focus on enablement for compliance analysts through automation. And today we're going to tell you a bit about how we're leveraging standard-based solutions like OSCAL to automate the verification of compliance control implementations for better understanding and visibility on your organization's continuous security posture. And like many organizations, we deal with complex compliance frameworks that apply to many systems, applications, and open source projects. And that real-world pain point is exactly what drove us to build the automation pattern that we'll share with you today. So let's take a realistic look at the now and the later. Lack of standardization across the compliance domain frequently results in data silos and ambiguity. As a result, the environment's left fragmented, making it difficult to achieve a clear, unified security posture in the now. So to cut through the complexity and establish a truly sustainable compliance program, you must firstly define and follow your own security and operational policy, eliminating any potential for internal ambiguity because no one knows your organization as well as you. Secondly, you must map that internal policy to your external compliance requirements to prepare for a more efficient and defensible later. And about preparedness for the later, well, with the evolving technological advancements from artificial intelligence to quantum computing, they all require security controls to support them. And with those, you have the evolving regulations, whether it be the HIPAA omnibus rules, the GDPR, or the landmark regulation of the European Union Cyber Resilience Act. All of these require a level set of pace and understanding of your organization's security posture in the now. So taking a look at where traditional compliance is in the now, it's running on security by checklist. And it's the manual annual nightmare where compliance is treated as a documentation exercise, not a security posture. It fails the later test because it's slow, mapping hundreds of controls across different teams and documents. And the screenshot of the configuration that passed last audit that's still in the spreadsheet is not going to automatically refresh for this audit. And it's ambiguous, leading to inconsistencies and audit findings. And lastly, it's audit focused, where there's more emphasis on the single minimum external request from an auditor, rather than objectively stating that because my organizational policy is defined and followed, my assets are secure. And where does this matter? Well, we're often constrained by these monolithic GRC tools. While once essential, are now frequently inflexible, proprietary, and they operate in silos. They create massive vendor lock-in, making it difficult and expensive to integrate with new security and automation technologies. Think of it this way. If your organization has the potential to integrate with new tools that you have available to you, but you can't integrate them into your GRC workflow, everything's incompatible, or that regulation changes, then you have to update it. Everything just becomes another spreadsheet. So what's a better way? Well, that's where OSCAL comes in, and OSCAL stands for the Open Security Controls Assessment Language, and it's a set of machine-readable formats expressed in YAML, JSON, and XML. The machine-readable artifacts allow for full visibility on the lifecycle of a security control. And the key benefit is traceability, and OSCAL follows a layered approach. And since we've already established that OSCAL is pretty complex, the reason being is because it was only ever supposed to be used for system-to-system communication. That's why it's imperative that all parties involved must speak OSCAL for those human-defined outcomes. From the control layer to the assessment layer, there are different personas associated with each. The control layer acting as the map for general guidance, where your regulations live. The implementation layer acting as the terrain, where your control implementations at the system level live. And the assessment layer acting as the roadblocks and inclement weather along the way, where you have your assessment plans and results, all with layered imports from the very beginning. And how did this happen? Well, through the traceability and people speaking OSCAL. So now I'll hand it over to Jen to tell you a bit about our solution.
Thanks, Hannah. All right. So I think you're all going to agree with me that security and compliance in cloud-native environments, it's pretty complex, right? And when you throw something like OSCAL into the mix, it just becomes another complex thing to learn. So that's why we want to rely on this toolkit here. So I'll start with OSCAL Compass. This is a CNCF sandbox project, and its main job is to leverage the OSCAL standard to automate our compliance workflows. And with specifically the Compliance-to-Policy project, which is a sub-project, it translates that high-level data in compliance, like what you might see in an OSCAL assessment plan, into lower level, maybe lowercase p policy data, which might be like a RIGO policy definition. And then we're using Open Policy Agent to enforce those granular policies across our application lifecycle. So think about how you might implement a deployment gate in your CI pipelines. You could rely on CompTest or the OPA CLI to help you in that area. And then finally, we move on to open telemetry, specifically the collector. And we're using the collector to take all that information that's emitted from our policy engines, like your logs, your metrics, or your traces, and complete our feedback loop by capturing those policy decisions and mapping it back to our compliance data. So here's how we're using all of these tools together in a methodology that we're going to just call the traceable path. And this path, it begins and it ends with OSCAL, but that traceability that Hannah was talking about that we get from OSCAL, it goes all the way into our policy as code layer. So I'll start with our rules, and this defines our organizational governance rules that are based on our compliance requirements, essentially defining our mandates and what we need to assess. And we pass this into our C2P, or Compliance to Policy tool, and the outcome is our policy as code. And this is where we're measuring our control effectiveness in our environment. And our policy as code, once it's available in our environment, we can use it with our OPA-based tooling to render decisions and help us with our enforcement actions at runtime. And those become evidence-generating events for compliance that can be captured with the open telemetry collector. And the collector at the configuration level, this is where we're defining what exactly do we need to collect as proof. Because typically you need to know what happened, when did it happen, and how does this fit into my overall governance framework. And then we use the open telemetry collector to export that information to a centralized store, like an evidence store or our open telemetry backend, where we use again during our audit phase, where we're going to rely on the C2P CLI again to tell us how we're actually stacking up against our external compliance requirements. And we use that type of information overlaid with the evidence we've collected to get actionable insights like, what controls do I have implemented? What do I not have implemented? What's not implemented correctly? And we use all of this information, we feed it back into our first step, our rules, turning this into a continuous feedback loop. So this methodology that I'm describing here, it can be used in various compliance scenarios, but we're going to explore a very specific scenario here on the next few slides. But I want to point out that we have some code snippets and workflows on the next few slides, and this was produced by some automation content that we have in a GitHub repository, and there's a QR code so you can access it at the end of the slides. So here we're going to start with a walkthrough of how we create those rules. So as you might have guessed, we have to start with our compliance layer. So here I've defined a few compliance requirements from different standards, and they all pertain to separation of duties and secure development processes. But like Hannah was saying, these are our minimum requirements. So we have to think of them as our jumping off point or our floor. And our real goal is to make sure that as we work through our governance layer, that these security controls are right-sized for our organizational needs. And that's where we move into our governance layer, where we have to start by defining our technology-specific controls. And in order to do that, we typically have to know what capabilities are in our environment or the types of components we have. And we need to create or adopt security best practices on how we secure those. And ideally, these types of controls could be community-driven and reusable. So I have a security control defined here. It's for separation of duties in my source code repository. So all code changes to production require peer review. I'm sure most of you guys are familiar with that one. And so now that I have this control defined, I can move it into my organizational policy. And this is the middle of our governance layer. And the right sizing is going to happen here, because here's where I'm going to define my compliance scope, and I'm going to tailor those controls to my unique organizational needs. And once I have this policy defined, I can move into my assessment procedure, which is where I'm taking my technical action. This is where I would define how I'm going to assess my control implementation in my specific environment. So now on to the good stuff, because now we can see that example here. So this is adapted from the Cloud Native Security Controls Catalog. And if anyone's familiar with the OSCAL schema here, you'll notice this is not OSCAL. This is actually represented in the Jamara logical model, and that is an open SSF project under the Orbit WG. And we use this as our governance first framework, but we still use OSCAL as our intermediate format when we need to exchange with tools that speak OSCAL or exchange with third parties, or when we want to create some formal compliance documentation. So a couple things I want to point out on the slides here. We have our security control, and we're mapping it to those compliance frameworks you see here on the left. And we say how this control fulfills those compliance requirements to varying degrees. And I also want to point out our assessment requirement ID, because this is a crucial part of our traceability. You're going to see it on later slides as we try to link back to this assessment requirement. All right, so now that we have created our organizational rules, we can create our policy bundle. But I said policy on the last slide, so I want to make a clarification here. We have our capital P policy, which is human readable. This describes our intent. But we also have what I'm going to say our lowercase p policy. This is the one you might be familiar with. This is our policy as code. This is our automated check. So now that I have that out of the way, I'm going to go through this workflow here. So we've created our organizational governance rules, and now we need to complete a compliance assessment. So we're going to export to our OSCAL assessment plan. This is going to be ingested by our C2P CLI, which will use it to determine what plugins are needed for the compliance assessment, what rules are in scope, and allow us to tune the parameters of the logic to our specific compliance use case. And it passes that information as a rule set to the applicable plugin. And here we have the OPA Rego plugin, which is going to create an OPA policy bundle for us in our local context, which we push to our container registry so it can be consumed as an OCI artifact. And here is the command we use with the C2P CLI to complete this step. All right, so let's take a look at what we just created here. On the left, we have an OSCAL assessment plan. And remember that control I mentioned, so we're coming back on it here. One of the ways we're going to check that that control is in place is by looking at our GitHub branch protections. So on the left, I have how I'm going to assess this in human readable format. And on the right, I have my Rego policy definition, which is how I'm going to assess this in an automated way. So notice the traceability between these two documents. I have that same identifier here on the left, GitHub branch protection, and the same on the right in my policy metadata, and you're also going to see it in the policy outcome. So I can link my assessment procedure to my automated check all the way to the outcome of that policy. So now that we have our policy as code in place, it's time to use it in our enforcement pipeline. So the first thing we're going to do is pull that policy back into our local context using our policy tool. We're going to query the GitHub API to get the current state of our branch protection rules, and we're going to feed that into our policy engine as structured input so it can determine if it's compliant with that policy we identified. But one thing will always be true when we're running this, we're always going to collect what happened with the open telemetry collector. So here I have a log snippet that we created using the debug collector, or the debug exporter, excuse me. And you'll see here that we have that GitHub branch protection identifier here. So we have traceability back to our assessment plan, but then we also have some new attributes, our compliance-based attributes. And this is going to help me connect my operational failure back to my original governance rule and impacted compliance frameworks. So just to talk a little bit about how we created this snippet. So we used the OpenTelemetry collector, and the first step we did was instrument our policy or assessment tool, and we deployed the collector in agent mode near that tool. And this is where we're getting some of that verifiability in the evidence. So we can get a trace ID for our transactional context, we get a timestamp for our temporal proof, and even a link back to our original policy. And that information is fed into the receiver component, and that's the first component in our collector pipeline. Here we're using OTLP. And then once that information is in our pipeline, we can pass it to our processor component. And this is where we're dynamically adding those compliance attributes based on what policy was executed and what the outcome is. So we're able to connect those policy decisions to our compliance data. And then finally, we push it to the exporter component. And this is where we send those logs to our backend based on our compliance rules. So you can send it based on the region or based on a specific attribute. Here we're using the debug exporter, and we're using an AWS S3 exporter to help us with our log retention requirements for long-term storage. And then we push to Loki for our near-term or real-time analysis. So this is the type of dashboard that we're able to create using this solution. So here I have a Grafana dashboard that we created. We're using Loki as a data source, and we're using logql to create these panels based on those attributes that we just added with the collector. So the point here is to visualize the technical effectiveness of our controls that we have implemented in a visual way. And I think this is a lot prettier than a spreadsheet. I hope you guys agree. But what else do we get over a spreadsheet with this solution? So we get structured, normalized information we can use to establish a baseline, and we can develop metrics around our control health. We can define thresholds for control failure rates, and we can configure proactive alerting when those thresholds are breached, so we know what compliance issues are happening when they're happening. All right, so we're at the home stretch here. We're creating the final audit artifact. So here I'm just going to talk through this workflow. We start with our assessment plan, and this time this has what the auditor needs to see, but we're prepared. We have all this information in our backend that we can query instead of going and running around looking for evidence. So this is again fed into the C2P CLI, and it creates a rule set. This time we're using an OPA Loki plugin that's going to use that rule set information to query the Loki API, where it's going to return all of the applicable logs that I need to use as evidence. And that plugin's going to interpret those logs because it understands our attributes, and it's going to pass that interpreted evidence onto my C2P CLI, where I'm going to aggregate it into an OSCAL assessment result. And here's an example of what that assessment result looks like that we just created. So like I kind of foreshadowed in the beginning here, you see those linked back to that assessment requirement there, and that traceability back to how we determined the outcome. So GitHub branch protection identifier again. And then at the bottom, take a look at that result we have there. So that's a normalized result value that we've created. This allows us to create OSCAL findings in our OSCAL assessment result, which we can use to mark our compliance requirements as satisfied or not satisfied. And then here's an interesting part in the middle. We have our relevant evidence. So say the auditor sees this observation, but they are like, I need to look at this actual log, and that often happens. This allows you to use the API query to retrieve that exact log that you used to create that observation. So to wrap up, I hope that your takeaway from this is creating this artifact is not our ultimate goal. Our ultimate goal is to make this artifact really easy and automated to create using our policy-driven security program. And I'm going to pass it back to Hannah to talk about next steps and how you can join us on this journey.
And I know you guys are probably all asking yourselves, sorry, where can I find this material? Where can I find the snippets from the presentation? Well, it's all in the open source SecurityCon OSCAL in Action source code repository. You can just scan the top QR code. And then where are we actually implementing this integration pattern? Well, Jen and I both are working on the Comply Time project, and that GitHub organization that's at the bottom in the second QR code has several projects there that are using this integration pattern. So thank you for attending, and we look forward to seeing your contributions. Any questions?
So traditional security governance, I don't know if this is on. So traditional security governance, there's a section that looks at the identities and compares the identities to entitlements, and then is used for risk. Why did you not start from the identities to try and build this compliance tool?
I'm not sure I'm fully understanding the question. So could you expand a little bit?
So tools like SailPoint and Savient are used for identity governance, where firms inventory all the people and their entitlements, and then based upon that, they try and understand the risk. And they said, well, because I know of all the people and I know their entitlements, therefore I'm able to govern. And I'm just curious why, I didn't hear you mention identity once, and I'm wondering why human identity didn't factor into this governance task that you were undertaking.
So I think that's a place that we're going to go, but really we're starting here with securing our source code repositories and just making sure that they're configured the way that we want them to be configured. So we're starting with security controls that pertain to that particular area.
Yeah, I was asking how does the backward compatibility works? Let's say we already have a baseline of OPA policies, but we want to use them to map against a framework like a compliance framework and then generate the YAML standards that you are putting. Is that a functionality today?
There's not a functionality to go the other way, if I'm understanding you correctly, like starting with your policies and moving to compliance. But what you could do is map those policies that you do have in place to an external standard and then use it that way, but it wouldn't generate that information just from your policies.